graduate research assistant at Fresno State, working under the guidance of Dr. Sharon Bennis and Dr. Ranjit Riyar. Today, I will be presenting to you my research titled Salinity Tolerance and Forage Quality Comparison in Four Varieties of Alfalfa Medicago Sativa. Alfalfa is an important forage and the most valued hay crop for California's dairy industry, which leads the nation in milk production. Statewide, alfalfa was grown on 515,000 acres in 2020, according to USNAS 2020 report, down from over 1 million acres in 2016. California alfalfa yields an average 7.1 tons per acre, nearly twice the US average due to long growing seasons that allow for more cuts per year and to breeding efforts to address changing conditions in climate, water availability, and soil quality. This, according to Geisler and Horwath, 2016. With increasing drought and irrigation water scarcity, lower quality irrigation waters that are often saline are increasingly used for forage irrigation. Alfalfa seed companies have seen this trend and invested considerable resources into breeding more salt-tolerant varieties, for example, Alpha Rex. In this experiment, 4 alfalfa cultivars are being evaluated at 5 different water salinity levels using a split plot design in an outdoor pot experiment. A companion germination test is also being conducted. The cultivars include 2 newly licensed varieties from Berkeley Seeds Incorporated, a salt-tolerant control, and a public control. Methods and materials. Soil saturation paste was tested to establish EC at the beginning of the trial and during the complete cycle. This in order to initiate and have a baseline to make sure that we knew what we had initiated with and what we ended with in the soil of the saline concentration. The seedlings were established under non-saline conditions and grown in large pots filled with 4-to-1 ferreted clay to peat moss soil mix in a greenhouse environment at the beginning of the trial. 4 cultivars were evaluated, 2 from Berkeley Seed, which was the B6604 and the B6269, a salt-tolerant control, the AZ90 and DCST, and the public control CUF 101. The 5 irrigation water salinity levels used was 0.5, 5, 10, 15, 20 decisiemens per meter. The design was a split plot design with 4 repetitions. The seedlings were established under non-saline conditions and grown in large pots filled with 4-to-1 ratio of braided clay to peat moss. As a nutrient solution, we applied 1/4 strength hogland that was applied every week. As salinization began, the plants were cut to the crown and harvested at 30, 59, and 88 days prior to flowering in the controls. Dry matter production was determined after each cutting, and a companion seed germination test was also conducted. The light gradient in the greenhouse was not meeting the required for growth and development of the plant. Therefore, the pots were moved to an outside area, as seen here on your left in the image. To irrigate, we used a battery-operated water timers calibrated to deliver every 12 hours 500 milliliters of water, and they were equipped with micro-emitters used to minimize the water loss and evaporation, as you see on your left side of the screen. We can see here the observation where we were actually trimming down the pots, and they were harvested every 3 to 4 weeks prior to flowering in the controls. The dry matter production and sodium and potassium accumulation in the shoot tissue will be presented and evaluated further down. We have still to process. As compared to the non-saline control 0.5 decisiemens, cumulative forage dry matter yield was reduced by 31% at both the highest salinity levels, 15 and 20 decisiemens respectively. There were no significant differences in cumulative shoot dry matter yield between varieties, nor dry matter yield at each cut. Exposure to 10 disc semen solution did not have a large effect on seed germination, whereas at 20 disc semen, germination was reduced substantially, particularly for varieties 1, 2, and 3. Variety 4, which is the 6604, had the highest germination percentage at 10 and 15 decimens. Plant growth in April, from April to November in 2021. During this trial, we noticed that the germination, and this is what some of the previous slides show, that there was some of the varieties that actually excelled in germination. Research continuation, germination trial. If you can see in images D and E, the seed germination trial using germination, we were using germination paper. In images F and G, seed germination using its own medium moistened with saline solutions. And you can see that the 6604 in comparison to the cuff 101 on your right has more germination. The same with the 6269 on the D and E. D is a 6269 at the 10 decimen level compared to the cuff 101 on the right, which has very little germination. Research continuation, the tables depicts the saline solution results. Solutions of the 0.5, 10, and 20 decimen were diluted using DI water. 500 milliliters were placed into an Ellenmeyer flask and autoclave for a total of 30 minutes. Once we completed that, the seeds were rinsed in any container used to irrigate the germination paper. Results and future work. In the second year of the study, some of the already established procedures and protocols will continue to be in use and will be modified to accommodate the new trial. We will continue the usage of conventional media. A longer term experiment with more cuttings will be conducted to differentiate variety salt tolerance. The pot experiment is being repeated using a 60-40 field soil to sand growing medium. The soil that we're going to be using is currently from the West Side San Joaquin Valley, and a second germination trial is currently underway. Further evaluation of the cultivars will be required to validate the initial findings. We will be using a recirculation flow capture tank that will hold any drainage from the pots and utilize later to irrigate the pots. We will also be in contact with the seed producers so we can have their input. At this time, I would like to acknowledge a huge thanks to my peers, Harmanpreet Sharma, Susana Lopez de Arriaga, for their support during activities in relation to the trial, to our undergraduate assistants, Osvaldo Escobar, Morgan Kagi, Gagan Gade, Israel Rangel, Juan Bravo, for their willingness to help us during times in which work can be excessive. A special acknowledgement to Stella Summer, safety coordinator, graduate laboratory assistant, for always checking out our chemical procedures, stepping out of her way so we can achieve our results. To Jeffrey Dervishian, Jordan Ag Research Center Safety Office Coordinator, for his help if all our analyses are done at JARC, and for helping develop protocols to run the analytical equipment. I would like also to acknowledge Dr. Sharon Bennis and Dr. Ranjit Vyar for their continuous support. My sincere thanks to Mr. Donnie Gray and Barclay Seed Incorporated for the opportunity given to evaluate their new alfalfa varieties. It has been a true pleasure and hoped to keep serving the company's needs soon. Thank you very much. And here to the right, I also incorporated this picture of this calf, where we consider that the feed that we grow for them eventually will turn around and they will come and feed us. Thank you all. Here's my references, and now I'm open to any questions available. Thank you.